Hello children, we met with a Form 1 first term mathematics lesson, chapter 10, Introducing Geometry. After discussing this lesson, you'll be able to identify what a fraction of a revolution is, the four main compass directions, what an angle is and the types of angles, the way of measuring and drawing angles, and calculating the unknown angles too. Let's go to the first part of the lesson, fraction of a revolution. Can you see the clock face here? Look at its second hand, which is in red color. What's happening there? Yes, you can see it's turning. So children, like that way, a complete turn is called a revolution. Now, let's see the way of finding the fraction of a revolution. Let's see this example. What fraction of a revolution does the second hand of a clock turn through when it starts at 12 and stops at 3? It's easy if we get a clock face to find the answer. In the question we can see the second hand has started at 12 and stops at 3. So, if we see the part of the hole on the clock face, we can see it's like a quarter. So children, here the fraction of a revolution is quarter. We can say the second hand turns through quarter of a revolution. Let's look at another example. What fraction of a revolution does the second hand of a clock turn through when it starts at 3 and stops at 12? Starts at 3 and stops at 12. We look at the part of the hole from 3 to 12. Yes, there we can see some number of quarters. Shall we count? 1, 2, 3. Yes, the fraction of the revolution is 3 quarters. Let's go to another example. What fraction of a revolution does the second hand of a clock turn through when it starts at 1 and stops at 7? Here even we can get the clock face and show how the second hand has turned from 1 to 7. If we see the turn of the second hand, it's like a half. So children, the second hand turns through half of a revolution. Are these difficult? No. These type of exercises can be seen in exercise 10A in page 167. In the exercises given in page 167, you learned the half of the revolution, quarter of a revolution, and also 3 quarters of a revolution. So here you can see some questions. So if you have practiced them, these won't be difficult for you to tell whether they are half, quarter or 3 quarters of a revolution. Shall we see? Look at the first one. What is the fraction of a revolution here, children? Yes, it is half. And if we see the second one, it's very easy. We can see it's a quarter. The next one even? Yes, it's a quarter of a revolution. Look at the next question. Is this quarter? No. These type of ones, we know it's 3 quarters of a revolution. In the next question even, from 10 to 1, yes, 3 quarters. and the last one from 3 to 6, 3/4. Let's see another example. Where does the second hand stop if it starts at 6 and turns to 3/4 of a revolution? See children, here you are given where the second hand has started and also the fraction of a revolution even. So what is the way of finding the answer? Yes, in the same way we have to show the given details on a clock face firstly. So we will show where has the second hand started. It has started at 6 and turns to 3/4. If we see 3/4 from 6, we can see it ends from 3. That means the second hand stops at 3. In the same way, different way, the same question can be asked. So, these type of questions can be given in page 168. Now you know what a quarter of a revolution, half of a revolution and 3/4 of a revolution, as we've discussed them in the first part of the lesson. So along with them, we'll go to the second part of the lesson, compass directions. Compass directions: north, east, south and west. These are the 4 main compass directions. I know that these are not difficult things as we've done them in last 2-3 previous years. Let's go to another example. If you stand facing north and turn anticlockwise to 3/4 of a revolution, in which direction are you facing? Anticlockwise direction means this side. Now from north we'll have to count the number of quarters. In the question it is said there are 3/4 of a revolution. So shall we count the number of quarters? 1, 2, 3. So that means you are then facing east. So children, like this way you will be given some exercises from 10b in page 168. Try to keep them completed. Now we are going to discuss the next part of the lesson, angles. Can you see the second hand of this clock face and see how it moves from one position to another? Did you see there's a space created in between the hands of this clock? How do we call that space? Yes, it is called an angle. Angle is a measure of turn between two lines. We measure angles in degrees using a protractor. As we discuss, the green color space created by these two red color straight lines is called an angle. So here these two red color straight lines are called the arms of the angle. And this is the place where these two straight lines meet together. It is called the vertex of the angle. These are the main parts of an angle: arms and the vertex. So we are given an angle here. Look at its shape. It's like an L. How do we call these L-shaped angles? Yes, these type of L-shaped angles are called right angles. And now we are going to discuss the relationship between right angles and fraction of revolution. Look at children. Here we can see two right angles. So can you tell me the fraction of revolution here? Yes, we can see a half of a revolution. Then for a half of a revolution, we can see there are two right angles. And now how many right angles are here? Yes, there are three. Then the fraction of the revolution? See, it's 3/4. So 3/4 of a revolution equals 3 right angles. Now we are given 4 right angles. What is the fraction of the revolution? Yes, 4 right angles. We can see it's like a complete revolution. That means for a complete revolution, there are 4 right angles. So, what's the relationship between right angles and the revolution? Yes, one right angle is equal to quarter of a revolution. 2 right angles equal to half of a revolution. 3 right angles equal to 3/4 of a revolution. And there are 4 right angles for a complete revolution. So, in the exercise 10C in page 169 asks you to write the number of right angles of different fractions of revolution. Try to keep them completed. Now, let's learn the types of angles. By considering the way of forming angles, we can categorize them into different types. We know these types of angles. They are right angles, which equal to 90 degrees. These smaller angles than a right angle are called acute angle, which less than 90 degrees. We meet some angles which are greater than 90 degrees too. They are called obtuse angles. This is a straight angle which equals to 180 degrees. Angles which are greater than straight angles are called reflex angles. They are greater than 180 degrees. And this is a full angle which equals to 360 degrees. So, here the types of the angles we learnt are acute angles, right angles, obtuse angles, straight angles, reflex angles and full angles. Now, look at the exercise 10D and try to identify the types of these given angles in page 170. Now we will discuss the angles of a revolution. So, what can be seen here? Yes, we can see a whole turn, a revolution here. And we can see how a complete revolution divided into equal parts. One complete revolution is divided into 360 parts and each part is called a degree. Degree. It is the measurement which is used to measure the size of an angle. The size of an angle is measured in degrees. So, I would like to ask you a question. These are the angles we learnt, and here you are shown a part of a revolution. It's a quarter of a revolution. So, can you tell me which type of angle is formed and what its size is? Yes, we can see it's a right angle. There we saw a quarter of a revolution equals to a right angle. Now, we will see the way of calculating the size of a right angle using the size of a complete revolution. A quarter of a revolution and a right angle are same in size. So we know there are 4 right angles to a complete revolution. A complete revolution means 360 degrees. If 360 degrees equal to 4 right angles, the size of a right angle can be calculated by dividing 360 into 4, as there are 4 right angles. So when we divide 360 into 4, the answer is 90 degrees. The size of a right angle is 90 degrees. When looking at this diagram, two things come to our mind. One, it shows us a quarter of a revolution. The second, we can see a right angle there which equals 90 degrees. So like that way, we can use the size of a right angle to find some fraction of revolution even. For an example, here we can see a half of a revolution. Now, if we want to get to know the size of this fraction of revolution in degrees, firstly we can check the number of right angles there. There, in this fraction of revolution, what do you think, children? How many right angles are there? Yes, there are 1 and 2. 2 right angles. So, if one right angle is equal to 90 degrees, 2 right angles will equal to 90 into 2, 180. 90 into 2, 180. In the same way, we can find this fraction of revolution even. Here, we know it's a 3/4 of revolution means, yes, there are 1, 2 and 3 right angles. So, if we want to calculate the size of 3/4 of revolution, we can multiply a size of a right angle by 3. 90 into 3 is 270 degrees. So like that way, in the exercises of page 171, asks you to find the size of some fractions of revolution. Try to find them even. We'll go to an example. How many degrees has the second hand of a clock turned true when it moves from 1 to 10? When it moves from 1 to 10. Here, do we know the fraction of revolution like quarter, half or 3/4? No. Then we can find, here we know altogether on a clock face there are 12 hours. That means each and every clock face is partitioned into 12 parts. So, here the fraction of the revolution can be get out of 12. Shall we see it? We'll see out of 12 what fraction of revolution here is. 1, 2, 3, 4, 5, 6, 7, 8, 9. The fraction of revolution is 9 over 12. So here the fraction of revolution is 9 over 12 of revolution. 9 over 12 of revolution. Now you know the size of the revolution. Yes, it's 360 degrees. That means the answer can be found by finding what 9 over 12 of 360 is. You know the method of simplifying this. Firstly, we can cancel 12 and 360 degrees. So 12 times 1 is 12. 12 times 30 is 360. Finally, 30 into 9, 270 degrees. So, the size formed of this revolution is 270 degrees. We'll see this example even. How many degrees has the second hand of a clock turned through when it moves from 7 to 9? This is the clock face. Second hand moves from 7 to 9. Here, can you tell me what fraction revolution this is? Yes, here you can see 1 and 2. The fraction of revolution is 2 over 12. So, to find the size formed here, we can find what 2 over 12 is. 2 over 12 of revolution means 2 over 12 of 360 degrees. Then, to simplify this, firstly we can cancel 12 and 360. You learnt the way in previous lessons. 12 times 1 is 12. 12 times 30 is 360. So, 30 into 2 is 60 degrees. 2 over 12 of a revolution is 60 degrees. Can you check exercise 10E in page 172 now?